now, and I start the screen sharing. Bildschirm Nummer 2. Okay. Chat window is here. Teilnehmer window is there. Mhm. Okay, and we had 10 people so far still missing. So I said we'll wait a bit to give anyone chance to arrive. There was a question in the chat, which version of Visual Studio will be used? We will be using the version 2022 as it's the newest one. And if there are any meaningful differences, technically any version of Visual Studio starting with 2015 is fine. Because since then Microsoft started to using a universal C runtime such that such that the binaries are even interchangeably compatible for the most part. So if you have any Visual Studio installed, then just stick with it. You don't need to install a newer version. Yeah, they also look mostly the same. Feel also quite similar. The main optical difference, graphical difference that you will notice with the, I think that starts with 2019, is that when you start it, it doesn't bring you to the main screen directly, but it opens some sort of quick start screen where you can just select one of the old projects or start a new project. It needs some getting used to, but it's not really a problem. And the old versions without the screen are just as usable, so there is no need to update from a technical standpoint. Yeah. Okay, any other questions? Okay, if there are no other questions, well, seems not. One more person arrived. That's good. So let's keep waiting. We have 2 more minutes until the announced 5 minutes of wait time for latecomers will be passed. Still, if you have any other questions, you can ask them. Okay, if not, then I'll maybe already start opening a it's a fresh Windows installation. So for those who don't have Visual Studio, we'll quickly look into how to install it. You can just go to the Microsoft's Visual Studio download website. Apparently it's there. There was another question in the chat about the recording. So the YouTube channel, I don't think it even has a name. It doesn't have enough views to be able to pick a name. It just has this numerical value. I will post a direct link to every recording into the Moodle so that you can just directly access the right recording on YouTube, and you can also from there see which channel it is and watch the last year's recordings. I don't know off the top of my head which which numerical ID it has, but I could look that up. Wait a second. YouTube.com. Need to log in with the right account. Konto wechseln. Okay, so that's the channel. the other different videos from the years past. And the 5 minutes are past, so we can start with the lecture. So yeah, the link is in the chat, and I will post another link into the chat, into the Zoom chat, the one where you can get the Visual Studio if you don't have it. So for starters, we'll just take a quick look into how to install it. So as you see that once you scroll down there are a couple download buttons. Apparently there is also a version for Mac, but from what I was told, it's not really feature complete, so it doesn't work that well. Although it's probably better than nothing. If you have a Mac and don't want to use Windows, then you could try it, and then let me know if it's any good. Okay, so from the 3 versions that are here to be downloaded, we just go for the Community Edition. Technically, it has almost all the relevant features of all the other editions, but is free to use. So the setup downloads, and we can open it. And once the setup is running, we will have to select the right components. So that's also one of the reasons why I'm showing this at the beginning, so that you can take a look which parts are needed. Yeah, it needs some time. Everything always needs time with computers, so being patient is a virtue. Okay, so on this screen we can select which parts we need, and for our application, the only thing we need is desktop Entwicklung. So in English it would be desktop development in C++, and there are already quite a few components pre-selected. Let's take a quick look. I think we can even leave it with the default selection of features. I don't think we will need anything else, and if we need, then we can later on select them. So where's the SDK? It's already installed the Windows 11 SDK. That is probably fine. And it's the newest one as well. Yeah, that's okay. We should probably add those components just to have everything we might potentially want. We can check on the einzelnen Komponente. Yeah, that should be all. The other ones are not so interesting. And what I always do is I select only the English language, because if you have it in German and then you try to search for something on an error message, a warning, or where a setting is on the internet, then the chance of finding it is severely reduced once you enter it in German. So it's really a good practice to just run the software like IDEs. So IDE stands for Integrated Development Environment, in the native English language, even if you personally would prefer another language. As long as English works for you, then it should be preferred. So while the installation runs here, we can switch to the other virtual machine, which already has a Visual Studio installed, and I will start a new project. So the way these exercises will work is that we start a project, something that I describe and tell you how it is supposed to work, and then some of the functionality of the project will be to be implemented during the exercises. I will set up some remote desktop for you so that you can access this virtual machine, and other parts of the project will be tasked as homework, so to be made during your homework. Both contributions will be graded, so your homework as well as your participation in the during the lecture. It is also an option to just present your homework during the lecture if you want. With regard to the homework modalities, the general idea is that you get a homework task during one lecture, and then you have ideally 2 lectures to implement it. So you have 1 lecture on which no solutions are expected. You can ask any questions if you have any questions regarding your homework that you would want to clarify before you finish your homework. And then, so after 2 weeks is the due date when the homework should be turned in. As long as the solution for the homework has not been presented during the lecture, if you turn it later in, it still will be counted. So it will depend on how the lecture goes and how it progresses, whether you only have the default 2 weeks or if you have a longer time period available to submit it. I would generally say don't count on more than this 2 weeks, but if for whatever reason, personal health, etc., you didn't manage to turn in the homework in time, and the homework hasn't been yet discussed during the lecture, you can just turn it in later, it will be fine. Okay, so is that clear so far? Okay, there was another question, how the solution should be submitted. So ideally, when you have Visual Studio, you have this project. So for example, this test 1, which I created earlier today. And as you see, once it has loaded, it is currently made up of what is this complaining? Well, that should not be complaining. It is made up of one file, but you can of course during your work on the project add additional files, some header, for example, and maybe some secondary source file. So you will have a couple files that make up your project, and when you then go in Explorer to where the project is saved, let's be just lazy, we can just copy the path from here. The way by default the projects are structured is that there is a solution file, and then there is a folder with the same name, inside which you have the actual project file plus the filter file. So the project file has the main presets, the filter file tells you in which virtual directories here which file is stored. As you see here, they actually are on the root level, and then you have the actual source files. So you can also, when creating a project, tell it to put the SLN file into the directory so that everything is in one place. This approach, as it's done by default here with the separate file, is preferable, because if you add additional projects, so for example, if your project is made up of a DLL and a exec that then loads the DLL and maybe another DLL and other components, etc., then you just have one SLN file which pretty much just contains a list of the projects and some presets with regard to building them together. So if we look inside, it's just an XML file, and it here has a reference to our project file, and here it has a configuration of the different platforms which have been already preset for the project by default. So ideally you can then open the SLN, it will open all your projects in one solution here. So this is preferable. And about the submission of the solutions, the idea is you just take those. So you go first in here. Now you don't see any folder, so let's first build it. When we build a project, it will compile it and create a couple folders. So it will create two folders. One is here, which has the name of the platform, so in this case x86, then inside the name of the configuration, in this case debug, so you can see them here. You can also select x64, then you could select x86, that would be the 32-bit version, and here you can select between debug and release. Generally the way this works is that a debug build is what you would want to deploy to your customers, or which you would want to use in productive use in your lab, while the debug build is a build on which you are working while you are developing the software, testing, setting breakpoints, etc. The main difference between those two, well, there are actually two, is one is that the debug build will not contain any optimization, so the release build will work much faster. It will have much better performance than a debug build. The downside of this is that even though you can create debug informations for a release build, and I would recommend you to do it, the way the optimizations work is that a lot of characteristics of your code might be lost, so the debug informations will not be as precise. While in the debug build, which doesn't have any optimizations, most lines of your code will be represented by actual code in the compiled project. So even if you have like temporary variables which are not needed and stuff, the compiler will just take everything as you write it. And the second difference is that in the debug build there will be additional checks added. So the code will execute a lot of additional functionality which is related to trying to find bugs, memory corruption, etc. In operation. So a release build might actually tolerate some certain extent of bugs and just work, even though it might at some later point express in unpredictable behavior because some memory corruption broke something. But a debug build, in contrary, will, as soon as a detectable issue with, for example, memory corruption, stack overflow, etc., is detected, will crash instantly and point you to where the issue originates, which is actually quite good, because if you have some memory corruption which then just expresses itself way further down somewhere at some inexplicable point, then you really don't have any clue what went wrong. You just see that the code did something that should be impossible. Some variables that should have a value have been null or whatever, and there is no really reasonable way to find such corruptions long time after the fact. So it's actually quite good that the debug builds are very prone to crashing at any irregularity, as it allows you to find the issue when it happens and not have to worry about problems further down. So as said, here on the level of your solution file, it contains just the exe, which is compiled, and the debug informations, while on the level here it contains all the object files, so the intermediate object files. And ideally the idea is that once you have this folder, you are done with your homework testing, you go back into the folder, you delete all the unnecessary temporary folders so that you don't waste space, then you go out and then you just zip the solution and the project folder together. This also then just takes a few kilobytes, so the deleted folder, if I undelete it, is quite big, so you don't want to, it's already 1 megabyte for an application that pretty much doesn't do anything except printing 1 line of text. So we don't want this intermediate data to clutter Moodle. And then you just upload this zip file to Moodle, and it's important to really zip everything and not just the SLN file. That is something that happens in the past with some students, that they either just uploaded the SLN file or just zip the SLN file. So now you really need to add the source files. Technically, if you want to really upload the absolute minimum, you don't need the SLN file, you only need the source files. So you could also just go into this directory and just zip those, because this is like the minimum required. Okay, gave it the wrong name, but let's say test1. This is absolutely the minimum required that is needed to make your program run. So I said the SLN file only has a list of projects which it contains, so you can from Visual Studio just open the project and it will recreate the SLN file without any issues. The project file itself is pretty useless because it only contains the information which file belong to it, and the important thing are the source files themselves. Okay, so that much to how to submit the homework. And so let's start with the first project. So I will quickly close the solution again. What was that? Close solution. And we will create a new project. So here you can select create new project in Visual Studio. So here it shows which types you already selected in the past. There are quite many. You can in theory filter them. For example, only C++, and platform you can select Windows, and you can select, well, there's still quite many. For example, in our case we would want console. It still shows you a lot of different options, but what we want is just this standard console app. So it doesn't provide a user interface. It just allows you to print text to the console, and if needed, read text from the console. And for the exercises, this is all that we will need. So now we can click next. And what we want to do, the projects that we'll be implementing during the exercises, so there will be probably 2 projects if time allows. One project will be a class which can represent an integer which is larger than what the hardware could represent natively. So normally on a 64-bit CPU, the largest machine type available, if you don't care for some vector extensions, is 64-bit. And of course, if you work with encryption or some other more exotic use cases, then you would like to be able to handle larger numbers, especially larger integer numbers. So for scientific applications, you would probably rather want something that's a floating point number, but for those, a normal double 64-bit floating point number as supported by hardware is usually good enough, because you don't need arbitrary precision. But for example, when you use when you create some encryption or use or implement other things which needs larger integers, then it is quite useful to have a class that can represent these large numbers, and integers are rather simple to handle, so creating a universal floating point number would be much more complicated. So as a first task, we'll create such a integer number that can have an arbitrary size, and the trick here is that we don't just want to have it represented, but we will want to make the class implement all the operators such that our object will behave like an integer. So you can use multiplication, division, addition, whatever operation that makes sense and you would want to use. It should be available. And we will want to implement it such that convenience features are available, so that you can have a variable of our large integer type, and then you can just add to it a normal integer, or multiply or divide it by a normal machine type integer. There are generally two approaches how this can be implemented. The more work, more work, but also more efficient approach is that we implement operators for all integer types that are relevant. This one option, and the other option is that we just rely on the constructor of our integer, of our large integer, such that if we have a operation, for example, our variable plus equals and then 1, let's say, then that the compiler can just at this point, not finding a directly matching operator, just call the constructor on big int for an integer 1. Then it will have a big int of type of the value 1, and then it will to the addition using just the operator which only handles big int objects. So both approaches are quite valid. I think we will start off with just going with the constructor options, and if we want later, we can then implement some optimized operators if we choose to do so. So we'll call our project BigInt. Then we can click create, and it already creates for us a very simple solution with a project called BigInt. The solution itself is also called BigInt. Then we have one file called also BigInt. I would recommend to rename it to main, because we will want to have a class called BigInt, and it is customary to call the file where the class is located with the same name as the class. So, and while our main file here, which has the C++ entry function main, will be used to implement some unit testings and just to play around with our BigInt class. So let's create a new class. What was that? Add new class. So you can of course create a class by just creating two empty files, and that's it. But Visual Studio has this convenience features like the class wizard. So let's call it C. It is customary to call to prefix a class name with a C, identifying that it's a class and not something else. But for the file itself, I would recommend not to have this prefix. We don't have any base class or alike, so we can just click on create, and voila. Now we have again here a BigInt CPP and a BigInt age. Okay, and the first thing what we will need will be some constructor. So let's quickly see what the installation is doing in the meantime. The installation is done. So once Visual Studio, so a short detour. Once Visual Studio finished installing, you have this option to either create an account, sign in, or skip for now. And with the Visual Studio Community Edition, it is such that if you don't configure an account, then after 30 days it will require you to create an account. It will not want to work without one. If you happen to have a professional or enterprise license, then you can use it without an account indefinitely. And you can also just create a, I guess, throwaway account just to activate it. So it doesn't require you to use it or use your real account. You can just do whatever you want. And also, if you Google the internet, there are ways to reset the 30-day timer so that you can then use it without an account forever. But for now, here we just skip this. If it accepted, then what you can select here is the graphical style. So this style I'm using here is this one. I like it, but it's pretty much up to you which one you prefer. And here you could also select some preset which of these different side panels should be open by default. I would leave this at general as well, but it's up to your preference, and you can change it later on as much as you want. It just, you can also change this setting. You can change anything. It is just which start preset that would start with. So that will also need a second. Okay, while this is thinking, let's go back here. So we create some constructor, we create a distractor, we define it as virtual, because we might want at some point later to derive some object, some more complex int maybe or something. So we create a body for our two functions. So as you hopefully know, in C++, you have your definitions in a header file and the actual function bodies in a CPP file. Yeah, if you have any questions, you can of course ask them at any time. Let's see, is this done? Yeah, and this is the screen you have already seen before, so you can also click here, continue without code. Then you go to the normal main window. As you know from older versions of Visual Studio, they started up in this window directly. And there you can also go on File and New and go from there. Just that here it opens a slightly different new project creation window. So yeah, that's that. I guess you don't need any more help with installing Visual Studio. If you have any troubles, you can write me an email at any point in time. And in principle, if you want to use something else like Xcode or Qt Creator on Linux, that would work as well. I mean, the way we write the code, so the source files will be platform independent, so it complicates things but would not be a deal breaker. So that would be up to you, but it makes my work easier if everything is just Visual Studio, because then it's faster to test the project submissions. Okay, so here we will first of all include our big int. Okay, and the way we will want to implement our integer is such that we will want to make it as having as good of a performance as possible. So, for example, you would want to be able to avoid copying the whole thing if copying it is not necessary. So usually, for example, when you have a function which returns a value, then unless it's a machine type, so if you are returning some more complex object, then it will invoke the assignment operator and the copy constructor, and it will result in quite some additional operations which we would like to avoid. So what we will implement for our integer is a mechanism called copy on write. So our object will contain another object which can be shared amongst multiple objects, and as long as none of the objects tries to write anything to the internal object, then the object remains shared. And only once one of the instances of our outer object tries to do something, so to modify the data in some way, then the outer object checks whether the inner object is actually shared or whether it is held exclusively, and if it is shared, then it creates a copy, dereferences the original, keeps the copy, and then makes a modification on the now exclusively held copy. This mechanism is quite useful when you want to increase the performance of your objects if they have some complex inner structure. For the integer use case as such, this mechanism is maybe a bit unnecessary, because the amount of data which we will probably have to copy around is not that big. But for the later project, which we'll try to implement in the second half of the lecture, where we will try to implement a custom string class there, since it's a string, it can have an arbitrary length, so it might be very, very large. So there it really is very useful to implement such a copy on write mechanism. So to do that, we will define some the inner object as protected. We can use a struct as can. Oops. Wait, is that turned off? Yeah. And inside, so here you see it has the advantage of giving a prefix letter, because then you can more or less reuse the same name just with a different prefix. In C++, structs and classes are functionally very similar. The main difference is that in a class, the default access rule is private, while in a struct, the default access rule is public. So here, if we have the constructors, we need to say that they will be public, otherwise they would be private, while here we don't need to say anything, it will just be public by default. So what we will need here will be some array that will hold the actual integer data, so our string, so our number, and we can go with something quite short. Should just maybe include, or let's define the hash. We can define as a type we call it a bigint chunk, because it will represent a part. So every element of this type will represent a part of our large integer. And let's go with unsigned char. So unsigned char is the smallest machine type that you can have, and ideally what one might want later on is to be able to change that to a bigger type. The advantage of that will be that the system, you will be able more efficiently to handle your data. Or you know what, maybe we should just start off with unsigned long. Then we have the more efficient version from the get-go. We should later test the code where that works with all the different integer sizes, just to be on the safe side. But for now, let's just define it as long, and here we will create a pointer to this type, p data, and we will want size t, where we store the size of our data array. Size, and here, since our chunk is not equal to 1 byte now, we have the choice whether we want size to be the count of chunks or be the actual size in bytes. So both approaches would be reasonable, and I think the more general approach, since we want the things to be easier mappable on the size of the entire big integer, we'll just go here in bytes. So when we will be allocating data, and our big int would be more than one byte in size, and we would need to divide it and then allocate the right amount of elements. And now the last thing, we will need a reference counter, which will allow us to know how many other outer objects are referencing one inner object. And if we want to do this in a way that is multi-thread safe, so that you can have an object which so you can have multiple objects which all share the same inner objects, and if you have different threads using those objects, then what you would want is you would want them not to go into some sort of race condition where you would end up in an inconsistent state. So what we will need here is a reference counter which can be accessed atomically, and there are on Windows generally two ways how this can be done. One is directly through functions which are defined in the Windows header. And the other one is to use functionality provided by the standard template library, which is platform independent. So for now we will go with that option. We need to include the atomic header, and then we have here in the std namespace, sorry, 2 points, std atomic, and then this atomic type, where we can, well, template for a type where we can specify a type of which we want this atomic variable to be. Let's go with integer. We don't need many, and we call it ref. So that's another thing I didn't say yet. Usually when we pick names, we can pick anything, but it is good practice to prefix the name with something that tells you what type this is. So for example, P is for pointer, U would be for unsigned integer, A would be for atomic, but it's just a convention. It does not have any meaning with regard to what the program does. For the program, a name is a name, whatever it is, doesn't matter. It just needs to be the same everywhere. And what we should also do is we should define this as mutable, so that we can in principle access it from const functions, just in case that might become necessary. Okay, so we have our object, and outside of it we will need a reference to our object, so we can there are two ways. We can either define it like this, or we could define it like that. So this is quite a nice thing about C++, that you can be very space saving if you want, but I think this is more pedagogically valuable. And what you also can do in modern C++ languages is you can, in your class definition, already define an initial value for your variable. So in older versions of C you could not do that. It would just not work. So you would need to go to your constructor, and then inside your constructor explicitly initialize all your variables with a starting value. And having a starting value is quite an important thing, because otherwise you have a undefined value inside, and then you cannot do anything. So if you would have like other variables which you initialize, which then would always reliably tell you whether other variables are used or not, then you could go without initializing them. But it is generally good practice to always initialize all machine type variables. If you have variables of the type of some object, so it's some complex type, like for example big int, then the constructor for this will always be invoked by the compiler, so you don't need to initialize them. But for the machine types like a pointer or integers, floats, etc., you should provide a initialization either inside your constructor or outside inside your class definition. Okay, and as said, this will be the only variable that will exist on our object, since everything else we want will be inside our shared object. Okay, so the next thing we will need will be probably some constructor that would allow us to to initialize our object with some value. So here we will use a constructor which will be a template. The idea is here to not have to write one constructor for every integer type there is, because there are like up to 4. So 1 byte, 2 bytes, 4 bytes, and 8 bytes on a 64-bit system. So if we use a template, we just save space. T value. And since it's a template, we need to write the body where the template is defined. We cannot write it here. What we could do is presumably to write just specializations of the template in the CPP file, but that would not be good practice, because it would restrict our template to only be used in certain cases. So what we want is to do it here. We already have this to be initialized. Then the next thing we'll need is we'll need to create this structure, because it does not yet exist. So let's create a function for that. Let's call it allocate data, and we'll give it a size 10 with the size that we want our data to be. And the size again will be as here in bytes. And the way this function works, it does not return a value. What it just does is it assigns a new object to our m pointer internally. Okay, so here we will just call our function. We will give it a body later. And what we need is we need to tell the function how large it should be. So we go with size of type. That will tell us how large this is. And since we wanted this to be in bytes, then we divide this by no, we don't divide. It's already what we needed. Size is in bytes. We don't need to add anything. So we have our size in bytes, and then later here we will need to copy the data. So we use memcopy. It's a standard function available in C and C++. It's defined in multiple headers, so it's almost everywhere available on Windows, on Linux, on Mac, on everything. And what it just does, it copies from one memory address to another. So first you specify the destination, so it will be our m pointer pdata. We don't care for the chunk size or anything at this point. And the source, there we need to pass a reference to our input variable, and of course we need to tell it how many bytes to copy, so we go with size of t again. We could instead here also use mptr size, but at this point the assumption is that they are identical. And size t evaluates in compile time to just a fixed number. So if you would compile the code, then you would just have here this being replaced with whatever the right number is. While if you would use m pointer size, then we would need to first dereference the pointer, do some pointer arithmetic, so it would require more computational effort. Yeah, so that's that. And now we need to have our function. First, what this function should do is check whether something is already allocated. So of course in the constructor this will not be the case, but if we arrive in this function from the assignment operator, where we are assigning one integer to another, we might of course then need to disconnect from whatever object we previously have been connected to. So we add another function for it. We could just call it detach. And the first thing we do here is just we call detach. We don't check whether there is something to detach to or not, because we will make detach do that internally. And at this opportunity we can also go to our destructor and call our detach from here as well, to ensure that we will free all the resources we might have allocated once this current object gets destroyed. So we want to deallocate this element if there is one, or just decrement the reference counter if it's shared with other objects. And since we are here, we can just have the function definitions and have the actual function body in our C++ file. Zack. Okay. What I like to do when writing code in the header is to save on lines. And so, for example, here, instead of this, write it like this, and maybe don't use empty lines, because generally it is quite helpful if the header is as short as possible, so that you can just read through it and see, okay, what is this class doing, without caring for the implementation artifacts, so how it is doing. So this how it is doing we'll just have here in our C++ file, where we don't need to save on lines. And in fact, using usually the more lines you use, the more readable the code is. Of course, like having multiple empty lines is usually pointless, but not writing like everything like one long sausage going down, but separating like in paragraphs functional blocks is quite a good practice, and makes the code more readable. Okay, so our detach function, and yes, I know that the first exercise sounds more like a lecture, but we need to prepare some base for you to be able to work with. So yeah, I will do that a bit more, and then we can try to do some screen sharing if we have time during this lecture already, or you will just get directly some homework. So, but well, let's proceed. So we check if there is no pointer, then we just return. that looks better. And now in our alloc function, okay, then we need to do something, but first we do our alloc function. So at this point we already know that there is nothing to deallocate. We could have a safety check if this is 0. So from our current constructor we will never arrive there, but maybe in future in some case we might pass a 0 value. So if it's 0 then just return, because we have nothing to do here either. Okay, and now once we are here we can now allocate a new object. So for this thing will be equals no, let's use a temporary variable for that, and then add another helper function, stern ptr is equals new subject. Well, right, and there is a thing to consider here. So if we do it like this, so with new, and then we would need to allocate a next have a second memory allocation for the actual data. And in principle we could we could implement it in a way that would allow us to have only one new operation, but we'll do this later as a optimization. So for now we just go the textbook way of doing everything step by step. New, then we need our new chunk type, and then we need to specify how many new things we want, and here we would have size divided by size of that will not work well. Size team, yeah. This will not work because oops, typo, size, because this if we pass a size which is smaller than chunk size, or which is bigger than, like a little bit bigger than the chunk size, not an exact multiple of chunk size, then this division will get rid of the rest. So we will either end up with 0 or end up with a fraction of a chunk too little. So what we will want to do here is first we do the division, and then we do the modulo operation, and if we get any rest, then this just gets increased by 1. So this way we get the right chunk count. Wait, why is it complaining? Oh, wait, that's not the right name. It's pointer data. That's the right one. Oh, next spec. It should be a struct, of course, and not C. Yeah. Now it's fine. Righto. And what we also want to do is we will set size. Now we have the next thing to decide what we want to set as size, because we could either set the size that was passed to us, or we would set the actual size, how large effectively our data block is. And I think since we might want to be able to work with arbitrary sizes and then really know what the size is that we got, let's go with setting the actual size of the data that we passed. Even if we might allocate a fraction of a chunk extra, that will just be unused memory. So yeah, that's that. And we have now created our one more thing. We don't need to initialize it yet. So let's now add the next function, which will which we call attach, and it will just attach a SBegin structure to the current object. Zack. And a small improvement, we will make the detach operation to be called by attach, not be called by our alloc data. We should improve on this as well. So we change this slightly. I don't like this autocomplete. We change this slightly here because we want to always call attach such that detach will be always called. So we change it such that we only then create the object if we actually create it. Otherwise, we just call attach with a empty pointer. So here it will be a check if nothing to attach, then return. Okay, and now we can do our attach finally. So we have our detach. We check whether there is something to attach to. And if there is, then ref punct what was it? Fetch add 1. So we want to increment the value by 1. And maybe just for good measure, we should initialize this. I think that will be auto-initialized anyways, but we can test it later. So we initialize it with 0, and here we increment it by 1. And of course, the last step is that we assign to our own pointer structure, which we now know is null because we have detached it before. To make it like this so that it looks nicer. The value, and now the last thing to do is here in our detach to handle the actual detach situation. So here again, if our pointer has nothing, then we do nothing. We already had it. And then the next thing is what we want to do is we want to check if the value, if the ref is 1, because if it is 1 and we are detaching, this means we can delete it, and that's it. And the next thing what we want to ensure is that so if you have 2 threads running, you can have one thread which will check the value whether it's 1, and the other thread, just after the first one checked, because of the timing not being defined, the timing is random, will then increment the value by 1, and then we still think the value is 1 and we want to delete the object, but the value actually became 2, and we have a problem. So the way this is solved is by using atomic operations. So an atomic operation is an operation which is implemented in the hardware of your processor in a way that it either will be executed entirely or it will, well, so basically normally there are 2 types of atomic operations. There are those that either is executed entirely or fails, and then you get a failure, or is implemented such that it will be executed entirely, and you will get some, and it will always be executed. So if you have a situation where 2 threads are trying to do something, one of the threads will be the first one, and the other one will be in a defined way the second one to try this operation. And in hardware, and the thing about these operations which is important is that they are usually made up of multiple steps. So if we only have like assign the number or increment a number, this is in itself already atomic. So even if you have 2 threads trying to do the same, depending on what the cache of the CPU will do, so on x86 this behaves differently than on ARM, you will either be able to reliably still do your incrementation, or you might end up in a situation where one of the incrementations will be kind of forgot because the other core will flash its cache after the other one did. On x86 usually you have a lot of cache coherency, so this doesn't manifest this way, but on ARM it does. That's is why it's always good to use in such situations these atomic operations, even if you kind of just are using the add portion of the fetch and add instruction. So the idea of the fetch and add instruction is that it increments the value by 1 and it returns you the old value that was before in this memory region. So for our decrement, we actually will need to use this second feature of our operation. So ptr, so we have an if our m pointer a reference, but then we are decrementing, so fetch and sub 1, so we decrement it by 1, and then we check whether the atomic instruction tells us that when we decremented it that it was 1 before that. So in this way, we can be sure that no other thread can jam into our operation. If it tries to do, then we will see that that the result will be, oh, it was already 2 because another thread managed to already increment it before. Okay, but if we know that it is 1, then we know that we can get rid of it. So first of all, we check whether okay, we check this. We should now check also whether the data is not null. I mean, it shouldn't be, but well, it just shouldn't be because we don't check here whether the new was successful. So we actually don't need to do that. We can just delete it. I like usually adding rather more than too many than too little checks. But sometimes if you know that it's not needed, then there is no point in doing it. And then what we do in any case in rdetach is that we will set our pointer to null. So usually in this particular scenario, we would not be worried about something increasing the count by 1, but rather we would be worried about if 2 threads try to call detach at the exact same time, that we might end up in a situation where both, so without the atomic operation, where both would think, oh, there are 2 references, or there were 2 references, so I don't need to delete it. But it would be wrong, because there are only 2. So using this atomic subtraction, in this case, we are sure that one thread will get a 2, and the second thread to do it will get the 1, and it will deallocate our resources, and we will not end up with a memory leak. The scenario described earlier with the increment will apply would apply here with the attach, but it's not that problematic. It would be a problem if one thread would try to delete it while the other one is trying to attach to an object. So there is still certain, let's say, amount of risk here when using multiple threads. So what you would want to, so while the inner object is guarded properly, what is not guarded is the external pointer which we have here. So if you have an object of the type cint, you should not access the same instance of the object from 2 threads at the same time. If you would want to do this, you would need to use some external means of thread synchronization. But everything that the object does internally is now with the data is now thread safe. So you can, once you just externally synchronize the access to the object, be sure that you won't have any troubles internally. And the reason why you need this internal synchronization is that your external code, the one that you will write that will use the cint, is usually not aware of what is happening inside it. So it doesn't know whether it needs to attach or detach or whatever. It just knows, I want to get rid of it, I want to assign the number, or I want to create a new one. And because it doesn't know that, then it will also not know when access to this internal object would need to be synchronized. That's why we have this internal synchronization mechanism. Okay, so we have our attach, which is quite simple. We have our detach. So at this point we could write some test code to test whether we can actually assign some data. So that would be a good task for one of you. I think it's also easy enough for the first lecture. I just have to check whether I actually have set up anything. I probably have not. So I will. There are 2 ways how we can try it. We could try this live share feature from Visual Studio, but in the past this did not work that well. So I will quickly install a remote desktop software on this, and then we will be able to just so you can go on the website. Well, maybe I should first show you the website where you need to go to get the client. So we'll just go with real VNC, and the viewer, so the client that you use to connect to things, is free to use. They changed their website a lot since the last time I were there. Get started now. They want to sign up. I mean, you could also just go for Ultra VNC, which is just completely free. They rename it to VNC Connect. I think they renamed it to VNC Connect. No, what, screw it. Let's go with the completely free option. Ultra VNC is completely free, and yeah, cookies. Don't care for cookies. Maybe we should add an ad blocker first. So I always use new virtual machines for the lectures. So essential things like ad blockers are not always out of the box. This is something that should be out of the box with any web browser, in my opinion. Okay, is it installed? It's installing. Okay, it is installed now. I can go back to uBlock Origin. Sorry, to the Ultra VNC. Okay, now we don't have any fake download buttons. Zack. Is it downloading or not? Let's go with the latest one. For your use case, you just need the zip. Okay, so that will be. I assume I will post the link to the chat. I assume that this should work. And there you have the VNC viewer, and there is the other tool. So for my use case, where we need to access this VM remotely, let's make a new. Let's make here a new folder. Did I close that? And bin. So I hope you are downloading it on your computers as well. And there are, of course, VNC clients for Mac and Linux and everything. So this is a quite standardized protocol. So within VNC, ausführen, Zugriff zulassen. So the password will be the password is in the chat, so that the people watching on YouTube will not know the password. Yes, that's okay. So that should be running. Let's quickly see which port is it on the standard port. The sockets. Yeah, it's on the standard port. No, ipconfig. Okay, that's my internal IP. I will need that in a second. And for you, the IP, I will put it in the chat. I will not show it in YouTube. So for you will need the IP that you see in the chat. I will just quickly need to check whether the port forwarding is set up. Probably it is not. And the question to you, who of you would want to do the first in lecture assignment? I promise it will not be difficult. Dienstweiterleitungen hinzufügen. Lecture VNC TCP port. What was it? 5900 IP 10, 17, 10, 25. Okay, the port forwarding should be set up. If one of you wants to try to connect, please do so. Any volunteers? Do I have to pick someone? How about Mr. Tim? Would Mr. Tim please try and connect?
Sure.
Did it work?
Not quite yet. 1 second.
I mean, it's possible that it won't work, but I hope it will. Actually, I can just try it from another internet connection. I have so many. Whether that actually works. Um. No, 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 that will not work. Wait a second. I need to change one thing, and you need to have a custom port. Because the port is already used for by another. Let's go with. Let's go with the port 6900. So you need to type the IP double point port. But let me quickly check whether this will work. Just to be on the safe side. Oops. Yeah. Well, for me myself it works, so now you should be able to connect as well. At least in theory. Yeah, it's loading. It's loading a bit slow, but it's fine. Okay, you can try.
I'm trying, but for some reason the password does not let me continue.
But it asks only for password or for password and user?
Just for password.
And you type the password and it doesn't work?
It stops letting me type after, I don't know, like 12 characters, 10 characters.
And, oh, no, okay, then I will just make it shorter. Wait, what was the setting? Admin properties. Oh yes, indeed, it just cut it. That's so stupid. Why does that only accept eight letters? Okay, let's go with 7. That's why people for real users are using the real VNC client, which is apparently much more secure. Okay, try the new password. Wait, I need to save that. I'm sure that can be changed somewhere, but they just try to be compatible with the oldest of old versions, I guess. Admin properties, advanced options. Well, but does the short password work? Yeah, probably.
Sure does.
It changed
Yes.
the icon. Yes, great. So, Mr. Tim, the assignment will be to create a object of type cBigInt and try assigning an integer to it, and then looking in the debugger whether it actually worked.
Oh, okay. So it's been a hot minute and I missed the first little bit of the lecture, so I'm gonna have to click through this for a second. So what's the goal of this library? Is it just to handle big integers?
Yes, exactly.
Okay.
And as you see, for now it cannot do much except holding one. So we will need to improve on that later on.
Okay. So to be honest, it's been a few years for C++, so you're gonna have to give me a hot minute.
Well, the assignment is quite easy. You create a variable of this type, and you just use the constructor to pass an int to it. So
Okay.
it's a one-line assignment.
What do we want to put in?
Something that is easy to recognize, maybe something in hex encoding, and then just, I don't know, 1, 2, 3, 4, 5, 6, 7, 8.
Okay. Can it read directly, or do I have to do the...
No, just 0x. Where would you need the what's the English word for it? Quotation marks for...
I think Python in some applications.
That is
But
sick.
actually, no. No, it should be.
That is just sick.
Yeah, right? I agree.
Well, make it something longer. Just or fill it with 1, 2, 3, 4 A, B, C, D.
Okay.
Yeah. Okay, and now do you know how to use the debugger on Visual Studio, or shall we quickly?
So let's go over it. That would be good.
Okay. So we need something to put a breakpoint on, ideally. So maybe in the next line you could just type return 0. We need to return something from main anyways. Although, in fact, for the main function, the compiler usually accepts it if you forget the return value, because it knows that whatever called main will not evaluate the return value usually anyways. But for other functions, usually it will throw an exception if you have a return value that... Not an exception, sorry. It will throw an error during compiling that you need to specify a return value. Okay, so you already put a breakpoint on it, then you can just run it by pressing the play button. Then it will compile it. And as you see on the right side, you will see the disassembly of the code. So this is not a standard window. This is one that you need to debug Windows. Where is the disassembly enabled here, or by pressing Ctrl Alt and D. But once you do it, it will just remember it and will keep all the windows that you want to have always open. Also, this other things we probably don't need yet, but let's keep them here. For now, we don't really need the disassembly. What is interesting for us is here the locals window, so it shows you all the local variables. The auto is kind of similar. It will show you things that it thinks that are relevant. So if you have too many variables, you can use this one. Registers only shows the machine registers. This is mostly interesting in combination with the disassembly window. And you can also have a watch. You can actually add more watches somewhere. Somewhere you can add more watches. The idea is that you can here type the names of which variables interest you, so that you only watch the ones that are relevant. But since we only have one, we can just use the locals tab. And as we see here, we have already 2 members. Do you know why we have 2 members despite of having defined just one? Or does anyone else knows? Okay, no one. So the __ VF pointer stands for a virtual function pointer, and it is used when we have virtual functions like here the distractor. So it is just one pointer. No matter how many virtual functions we will have, it will always be one, and it is then pointing to a table of individual function pointers for the different virtual functions. If we would not have any single virtual function in this function, then this member would not exist. And of course, the other one is the one we have created. And there we can there we can inspect it. We can see, it has one reference, as expected. It has a size of 4, which is correct. If we go back to main, we see we have here a 32-bit integer. So we expect it to cast to a 4-byte long type, and then we have, of course, our pointer to our data. And can we copy that somehow? Copy, not copy value. I think this works. Yeah. Well, we can get the address from it, and if we have the address, we can go there. Wait, was it that? That is the address. But something didn't work as expected because it does not contain the right value. We can switch here to hex view. No, that. Wait, what? Did I mistype something? Let's copy it again. Copy value. Sorry, yes, it is here. Yeah, so actually it has the right value. I was just I was accidentally looking on the watching on the wrong column. What we can actually do when entering numbers up to 32-bit, it doesn't work with 64-bit, unfortunately. We can so of course we can just use a single character. Let's say A. Then we just check again, do the same test. Now of course the address in memory will have changed, so this is showing garbage. So we need to get the address. Copy value. And we'll also notice that only A is A and the rest are like CD, 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 which just indicates that it's not, actually it should be, I think, CC, it doesn't matter. The debug build initializes unused memory with a pattern. And apparently CD is used for, alright, it uses CD if it's created and it's not initialized, and it's using DD if it was deleted. So if you are freeing some memory, since the memory being freed might not become invalid instantly. So usually the way it works is the internal memory allocation allocates large amounts of memory within the application. Let's say at least one page, so at least 4 kilobyte. And then it will give you small portions of this memory when you make new or malloc. And if you then make free, then it will just mark on the internal table that this region is free, but it will not tell the operating system to invalidate the page because other parts of this page are still used probably by other parts of your program. It will only deallocate entire pages or multiple pages once it sees that there is a lot of free memory internally. So you can delete an object and the memory remains valid. And this of course is bad because if you then try to access this object by accident, or rather by mistake, let's say, then it might to some extent work. And of course if we overwrite the whole data of the object with an invalid value, then you have a very good chance that if you try to access it, it will cause a crash very quickly, so you will be able to find where you have accessed a already freed object. So this is called the use after free bug, and it's bad. You should not do it. But anyhow, so we see that the A was initialized, the rest of our chunk is empty. The size still, however, says 1. As we said earlier, we want the actual size, no matter how big our chunk is. But what we can do here actually is we can write up to 4 characters inside this quotation marks, the single quotation marks. So for a single character, you would use, of course, single quotation marks for a char. But if you want to write a string, you would use double quotation marks. But you can actually put multiple chars in single quotation marks, and this will create you the 32-bit value, which would represent those 4 characters one after the other. It might be useful in some scenarios, but it's usually not something that is commonly used. But it helps in our case because this way we can easily put a recognizable value here. Although you notice that the sequence has been reversed. This is an artifact of how x86 is representing integers in memory, and the way this and the way this works is that it wants to make it easy for you when you have a memory address to get the smallest part of the integer first, in contrary to getting the most significant part of it. So if you cast integers or pointers to integers, as long as you cast down, it is you will just lose data, but the smaller amount will be fine. And if you not use if you cast not pointers but the actual integers to larger ones, it will just fill up the upper bits with either zeros or ones, depending on whether it's a positive or negative value. And this effect here reverses the order. And on ARM architecture, it's in fact usually the same, although there is kind of a CPU flag which could be set during boot that you want to reverse the order. So switch from big endian, which one is which? I think from little endian to big endian encoding, which it might make sense on some very simple network hardware to do it, or in special cases, but nowadays pretty much no one is using that at all. So you can usually expect everything to be encoded the same way as x86 does it, which is quite nice because that gives you quite a good portability of your data. So you can have some file with binary data, and then you can load it on an ARM CPU without any additional need to convert data types or monkey around with them. Right here, so this works as I said already quite okay. So one more thing which we might want to add, since we have 8 more minutes left, would be to create an assignment operator so that we can write somewhere something is equals to. That is usually a very nice thing to do. And the assignment operator will be, let's say it will be surprisingly simple. So we implement it here. The assignment operator returns an object of the type which we currently have. Is equals. As an argument, it takes a const pointer to the other element that we want to assign. And internally, because we have already all these nice helper functions, all we need to do effectively is to just say attach other dot pointer, and then since we need to kind of return ourselves, what we do is we return asterisk this. Okay, so now what we can do is we can create another variable, my int2, and we can assign our variable to it. And there is one more thing we are missing, which we should add just to have full completeness today. This will be the copy constructor, which is quite alright. And we could theoretically put the body here into the CPP file, but let's not do it. The copy constructor is even more trivial because it doesn't return anything. The copy constructor, like the other constructor, takes something to initialize, but in this case it just takes the other element, and then it just makes the attachment. And since we have everything already initialized here, then this really is as simple as is. Okay, let's quickly test it. So in this case, we can put a breakpoint here. We will want to step through the function. And when we do it, we see that actually it uses the copy constructor, not the assignment operator. Well, we don't care what attach is doing. So it's actually quite quite smart, but we could also, of course, force it to use the assignment operator. I think if you wouldn't have the copy constructor, it would probably in this case also default to using the assignment operator, but you see at least that it does it tries to do some optimizations already, even though it's a debug build. And now in this case we just go to our assignment operator. Okay, and now talking about assignments, homework assignment. Your homework assignment for the next time will be to add a function which prints the value out as a string. So since we want to make things not too complicated, we can use the std string library. std string. So VString is a white string, which means it uses Unicode characters, which can represent all the different languages around the world, not just the American standard alphabet, which would be ASCII. So we just use VString, and it's a good practice to use VString wherever you can, because it then allows you to much easier port your application to other languages if you would want to. So we call the function toHex, and it's a const function. So const means the function is not allowed to modify any data inside. And let's create a string hex. Oh, let's call it hex. No, let's call it hex. Doesn't matter. We can call it whatever we want. You can rename it later. And here, to do homework 1. Convert the integer to hexadecimal representation. And I guess since we are at it, we should have a second function which is called fromHex, which does the opposite. And here, since we want to be efficient, we pass a const reference on a value. This one is not const. And bol is, so the idea is the function, if it succeeds, it returns true. If it doesn't succeed, it returns false, because since you are feeding it a string, you can feed it blah or bloop or tralala, and then it should just fail. If you just feed it with then it's actually a valid hexadecimal number. So yeah, talking about hexadecimal numbers, there are conventions where you would, for example, want the number to have a 0x prefix. Which one we chose here is, I guess, not relevant. Let's say that we say that it has to have a prefix. So yep, and for our conversion, so 1 to do 2, or so let's call it 1a and 1b, because it's kind of the same. 1b. The binary representation. And don't fail. So we want, so if we expect the string to be prefixed with 0x, but if we get one which is not, if it's otherwise still a valid hex string, then we don't fail. And of course, if we fail, then of course on fail. Or we won't always reset it to 0. Yeah, we don't want it return false, and to null. On success, that's trivial. So we can make it at least slightly simpler. Then of course at start we just detach whatever was attached. Yes, and we of course need here to add the prefix, and we are out of time. 1 minute left to spare. Any questions? No questions? Okay. So I will upload the project file to Moodle. I will upload the recording to YouTube. I will make a homework assignment on Moodle with this homework for you. And what else to say? Yes, and of course there is the expectation that you don't just implement those functions, but also in the main function provide some code to test whether the functions work. So for the this one is trivial. You just copy it to string and print the string to console or something like that. For this one, it would be good if you would have a valid and an invalid test case, so that you can check how it behaves in case of blah or bloop being passed instead of A, B, B, A, B, C or something that is a valid hexadecimal representation. Right, maybe one more thing. It should accept upper and lowercase. And the other function, let's modify it. With a default parameter where you can specify whether it should use uppercase or lowercase. So if it's set to true, you make it lowercase, else you make it uppercase. Yeah, that's it. Time's up. So I guess we'll see some of you later today for the lecture, and those which we don't, then we'll see those you in next week. So yeah, see you. Bye bye.
See you. Thank you.
Thank you.
Thank you.
Bye.
Bye bye.